Hello students, we are going ahead and working on lesson 6 out of chapter 1 today. So it is called Least Common Multiple. So have your books open to page 38 and we will go ahead and get started with our learning target. At the top right hand corner of your journal, let's go ahead and write in our new learning target today, which says I can find the least common multiple of 2 or more numbers. So we'll go ahead and write that in. I can find the least common multiple of 2 or more numbers. So yesterday we looked at greatest common factor. So now we're looking at the least common multiple. So a little bit of vocabulary to start with. The abbreviated version of this is going to be LCM. The C for common, of course, they have to have it on both lists. Least this time, meaning we're looking for the lowest one they share on both lists. And multiple, meaning above the numbers. So we're going to write out least common multiple. And because multiples and factors get kind of mixed up, we're going to underline multiple and we're going to show that it is above the numbers. Okay, so multiples are higher, factors are lower. That should be an E there. So we're going to get right to it and get to our examples. So example 1 on page 38 says find the least common multiple of 4 and 6. So we're finding the LCM of 4 and 6. I'm going to start out the same way we did on our factor lesson by putting the numbers at the top. Now, for this one, we're going to go ahead and do the strategy called listing multiples. So we're going to list some multiples of 4 and list some multiples of 6. Now, you can continue listing multiples forever and ever and ever, but what I like to do is list the first 3, and see if we can see and identifying multiples that are common. So the first multiple of 4, remember we're going above the numbers, is the actual number itself, so 4. Now we're going to count by 4s and list a few more of these. So if we count 4s, we have an 8 and a 12, 16. So there's a few of the multiples of 4. If we go over here and list some 6s, we're going to start with the number itself. So we start with 6. So now we're going to add 6s each time. So we have 12, 18, 24. If we look at our lists, within the first 4, I see some things in common. I see that this list has a 12, and I also see that this list has a 12. There's nothing lower than that they share in common. So 12 would be the LCM for 4 and 6. Now, it's good that they say least common multiple, because if they said greatest common multiple, we would be listing these for days and days and days until we found the one that's the highest. So when you're going above the numbers, you're looking for the lowest one on the list. There are some on your owns to try if you'd like on page 38, right after example 1. There's 3 of them there. So go ahead and pause the video, try those out if you'd like. Okay, number 1's LCM is 24, number 2 is 36, and number 3 is 30. We'll go ahead and try out example 2 next. Still working on LCM, but we're going to go ahead and do a different strategy of finding it. So example 2 is all about finding the LCM, least common multiple, using prime factorization. This is just a different way you can find it. If you start listing out your multiples and you're finding that the list is just going on and on and on and on forever, you might want to try using a prime factorization instead. So if we want to find the least common multiple of 16 and 20. We can use factor trees, just like we did for factors. So what we'll do is we'll go ahead and factor these out all the way down to their primes. So 16 can be divided by 4 and 4. And then those can be divided by 2 and 2, which are primes. And same thing over here, 2 and 2, which are primes. 20, we can cut that down 10 times 2. 2 is prime. We could go 5 times 2. 2 is prime and 5 is prime. And we have them factored. Once you factor them, we're going to do something a little different than we did for the factors. So what we're going to do is create a list of all the things that are on both lists. So I see a 2 here and a 2 here. So we're going to list that. Takes care of those 2's. Another 2 and another 2. Now there's nothing else they have in common, but we're not trying to find the factor. We're trying to find a multiple. So we have to list everything else. So that's where the difference is. So we're going to list another 2 and another 2. And we're going to list this 5. So I'm going to keep listing until all of my items have a line underneath them. That is a 5, by the way. Let me try to write that again. So now if I do this multiplication, I am going to find my least common multiple. So 2 times 2 would give me 4. That 4 times 2 would give me 8. That 8 times 2 would give me 16. And that 16 times 5 would give me a total of 80. So 80 is going to be our least common multiple for the numbers 16 and 20. And I don't know about you, but I don't think I would have just guessed 80 right off the bat because it's a little bit higher. So these prime factorization trees do definitely help find it a little bit quicker. If you want to try some on your own, 4, 5, and 6 on the bottom of 38 are there for you. Go ahead and pause the video and work on those if you've got a little bit extra time. Number 4's answer is 126. Number 5 is 252. And number 6 is 360. So now let's shift our eyes to the next page in our books. That's going to be page 39. In this one, example 3 is asking us to find the lowest common multiple of 3 different numbers. So we're going to use the same strategies we learned, but there's 3 numbers instead of 2. So example 3. We're still finding the LCM. And this time we're going to list 3 numbers. So I'm going to start down here. Our 3 numbers are 4, 15, and 18. Now, I'm not a huge fan of counting by 18s, so I'm going to use the factor tree method and factor all of these numbers out in order to find our lowest common multiple. So the way we factor the 4, remember, is 2 times 2. 2's are prime. 15, 5 times 3, and 5 and 3 are prime. 18, 9 times 2, the 9 is prime. And then we can factor the 9 out by going 3 times 3, and the 2 3's are prime. So now that they're factored, we're going to make sure we have every item listed to be multiplied. So here's a 2, and this one doesn't have a 2, this one does. So those 2 are represented with this 2. Another 2, no more 2's, no more 2's, but we still have to have it represented. A 5, and this one does not have any 5's, but we still have to represent that 5. A 3 and a 3, and then another 3. Remember, we go until we have everything underlined and used. So if I do this math, I will be able to get my final lowest common multiple. 2 times 2 would give me 4. 4 times 5 would give me 20. 20 times 3 would give me 60. And 60 times 3 would give me 180. So if I want to find the lowest common multiple of 4, 15, and 18, it would be 180. All right, so we have one more example to try out, and we'll do that on the very next page. If you'd like to do the on your own 7, 8, and 9, you can go ahead and pause the video now before we get to that next example. So number 7, the LCM is 40. Number 8, the LCM is 60. And for number 9, it asks for writing a set of numbers where the lowest common multiple would be 100. There's multiple things you could write here, but one answer would be 4, 10, and 25. That's one option that you could have written. So we'll go ahead and get set up for example 4. So example 4 is our real-life application question. A traffic light changes every 30 seconds, and another traffic light changes every 40 seconds. Both lights just changed. After how many minutes will both lights change at the same time again? So really, this is an LCM question because you're going to list the multiples of 30 and list the multiples of 40 and figure out when the very first time is that they're going to meet up again. So I'm going to write out a little bit of information that they give us. We're talking about traffic lights here, just so that we pull out the important info. One changes every 30 seconds, and one changes every 40 seconds. And so we're trying to find the LCM of 30 and 40. Now, for me, counting by 30s is pretty simple. Counting by 40s is pretty simple. So I think that I'm going to be able to just make a list of multiples here in order to figure out this answer. So what I would do is start with a 30. We always start with the same number and then just add 30s every time. So we have 60, 90, 120. So there's about 4. Let's come over here. We start with 40 and add 40s every time. So we've got 80, 120, 160. So there's about 4. Now if we look at anything in common, both lists share a 120. And there's nothing lower on either list that they share in common. So our final answer is 120. So that means our LCM is 120. If we go back to what this is asking us, it says, after how many minutes will both lights change at the same time again? So we just found the number of seconds, 120 seconds. If the question is asking us for how many minutes, we have to figure out 120 seconds equals how many minutes. So we have to remember how many seconds are in 1 minute, and there's 60 seconds equals 1 minute. So we have to figure out how many 60s are in 120. And there are 2 60s in 120. So this would become 2 minutes. So after 2 minutes, both traffic lights will change at the very same time again. There's one on your own if you'd like to try it on page 39 at the bottom. Go ahead and pause the video if you'd like to try that one. So this is a what if question. So it says, what if that last example, the traffic light that changes every 40 seconds, is adjusted to every 45 seconds? So if you redid your work and your lists, both lights just changed, and how many minutes will they both change at the same time again? The answer would be 90 seconds or 1.5 minutes if you converted it into minutes. That completes our next video, our lesson 6 video. Page 40 and page 41 in your math books is where we're going to pull our practice assignments from. So go ahead and work on some of those if you want some extra practice beyond what we do in class.